questions I normally ask. Let's say that this is a study somebody did about how many TVs people have in their house. You guys understand? So how many people in the study, what percentage of the people in the study had no TVs? 12%, right? And then up to 5, like the dude in that soccer commercial from a long time ago, where he opens his drawer and there's a TV of the game, and he opens the bathroom and there's a TV of the game. So what percentage of this study found people, what percentage of the people had less than 5 TVs? Less than 5, not at most 5. Yeah, so the shortcut is 1 minus 0.14. Because the opposite probability is easier to calculate. What's the opposite of less than 5 in this case? 5. That's 0.14, so it's less than 5. It's probably less than that. 1 minus 0.14. That's an extension of the whole at least one thing. It always works. So try to generalize it. If the opposite probability is quicker, do that and then do 1 minus that. Hell yeah. Right? Or you just add up 4 through 0, get the same damn number, of course. And it kind of mathematically is silly because, of course, you get the same number because all those probabilities have to add up to be freaking 1. So if you're only leaving out 0.14, 1 minus 0.14 is your answer. Right? So let's actually do what I asked you to. If you're doing this in the calculator, here's how you would do it. List 3, you want it to be what? Yeah, list 1 times list 2. All your x's times your p of x's. So list 3, highlight it, and you say list 1. Oh, you can do it, Jeff. What we'll do with that? List 1 and list 2. There you go. Bam. So those numbers look familiar? Is that good? All right. And then list 4, what do I want it to be? Yeah, you could do either list 1 squared times list 2. That would be x squared p of x. Or you could do list 1 times list 3. Either way. So if I do list 1 times list 3, do those numbers look familiar? All right. Now let me see if you guys can handle this one I'm about to show you. Because you want the sum of both of those things, don't you? Do you? The sum of L3 and L4. The sum of L3 would be exactly what? Not the number, but what would it represent? The mean. I love it. And the sum of L4 is not the variance. It's the thing that the formula needs, right? A lot of people just square root it and say they're done. But the sum of L4 would just be this piece. Right? But I still need it. So let me show you a much better way to do it than going into that list and getting sum and all that kind of shit. Do this. Let me see if you guys can handle this. Go to Stat, Calc, and I want to do 2 things at once. 2 var stats. Why would I want to do that? Because I want the sum of L3 and the sum of L4. I want the calculator to do both at once. You don't have to do this. You can do sum L3, sum L4 like we did before. You can go into list and all that kind of crap. Or you can do this. Tell it L3, comma. This is why your calculator has punctuation. Now watch, which one of these numbers means anything to me? 2.82, that's the sum, right? So the calculator considers L3 to be my x variables, right? So that means that xp of x, you got blah, 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 and you add it up, you should have gotten 2.82. If you did, you're on the right track. Now if you scroll down, look what do you think the calculator is going to call the other column of data? Oh my God, it's amazing. Right? And of course, all I want is the sum. All this other stuff doesn't mean a damn thing to me. It's just the quickest way to get the sums. So this next column, the sum would be 10.22. Right? So this is the sum of x squared p of x, and this is the sum of x p of x. All right, let me stop there for a second. And now you just got to throw things in the right place. This is nice. That is the mean. And why does that make sense where it is? This is sort of symmetric, but there's more stuff up here, right? So it pulled it up towards 2.8 instead of being right at 2.5. Does that make sense? That's why it's a little higher than it would have been just for those numbers. So let's see what the formula comes out with. So the mean is 2.82. So the variance will be 10.22 minus that dude squared. What do you get for that? Blah, 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 right? Was just that? No blah. Does that agree with what you guys got? If not, you desperately want to find out why not. Real quick, if you got a negative number here, what would that mean?
Distance can't be square root.
That would mean you made a mistake. It's entirely your bad, right? You made a mistake because there's no way that can come out negative. Now, if you make a mistake, it can come out negative all day long. So if you round the mean too much or something, you make it 3. Let's see if it'll work. No, here it won't work. 3 squared is 9, but you can imagine if you rounded too much, this difference might come out to be negative. So you really, really don't want to round this much at all, if at all. You guys with it? No reaction. All right. That's the variance. What's the standard deviation?
1.505.
1.505. 506?
505.
I like that. Get your face. Yeah, that's stats, man. Give or take. So let me show you the ultimate shortcut. You know this calculator costs a lot of money. Either you or somebody you know. Or somebody you don't know. I'm not going to make any judgments. So this bad boy can just give us these things directly. And you know that's never enough work for me. So it's too damn bad. Don't tell me what buttons you press. But you can actually, tell me. Now let me see if you guys get this. The full story of the data is where? In which list or lists? Where's the full story of the data? If this is the full story of the data, then I only have 6 data points. Is that true? No. I probably have a lot more data points because 12% are 0. So where's my full story of what my data is? Yeah. No. List 1 and list 2. These together tell me what my data is, right? 29% of my data is 3s. 21% is 4s. Without this and without this, I don't know what my data is. Do you guys understand that? How many variables are up there, though? I know we just did that thing. I don't want that to confuse you. That was just a shortcut that I can get 2 columns added together quickly. How many true variables are there in this problem? X, 1. How many TVs? It's a variable because it has several values, but it's one variable. I only had one question. How many TVs you got? What kind is it? Are you going to be home tonight? No. So watch this. It's kind of nice. Here's the ultimate shortcut that you do at the end just to check yourself. You ready? So you go to stat, calc, 1var stats like always. But now you got to tell it, oh yeah, my data is in L1, comma, L2. Now watch the cool stuff this thing tells me. Bam. It's only got the symbol for X bar. It wants to do a mu, but it can't. They didn't program it for that, I guess. So you got 2.82 is the mean. Sum of X squared looks familiar, right? That's actually going to be this piece here, the 10.22. It doesn't tell me S. Why not? It can't be. Why? I kind of forgot to say this, but why must this be this symbol? What's on the bottom if it's S? What's on the bottom? N minus 1. But what's always on the bottom of P of X? N. So it's built to be a population variance, right? So that's why the calculator goes, oh, you're doing probability shit. All right, I'm going to just still use sigma. And is that what we got? I didn't even look. Yeah, that's what we got, right? Yeah, that's what we got. Be good. Thank God. All right, is everybody there? Is everybody there? I love some of your face. I got some reactions that time. That time I got like, all right, so what about the second part to this question? So that's the first part. Real quick, does this data look like it could be normal? Starts kind of low, and then it goes high and goes back to low. It looks roughly normal. It looks a lot better than the last set of data did. So part 2 says, what percentage is within one step of the mean? So if I go one step up, where do I end up? 4.3, blah, blah, blah. And one step down, 1.3, blah, blah, blah. So what data points are in there? 2 to 4. And if you add these up, what percentage do you get? 67. Which is really, really close to what important number? 68. So that's decent evidence that this might come. If this is a sample I took, I know the work has to look at it like it's a population, but it's decent evidence that it came from a normal distribution. Maybe. So sometimes I will ask you, does it look like this could have been from a normal distribution? You look to see how close that is to what it's supposed to be.
How do you do the comma?
Oh, right above the number 7.
I won't put it there.
Aw. Evil thing. Your button might be stuck. Oh, I see. You guys got this. Oh, the frequency list. So you tell it L1 and you tell it L2. Yeah, that's fine. I forgot that there's that different setup. Does anybody else use calculator to do that? Okay. I always forget. Guys, if your calculator, I got to download like the most recent thing for this. What's it say? It says, what's the first thing say? This one's like frequency list, right?
It's list, then frequency list.
Okay. So does anybody else look, and then down here's calculate or something, right?
Yeah.
If yours looks like this, your list is L1. That's your list of data. And then the frequency, it makes sense, because what would this really be? This would be the relative frequency. Right? 12 out of 100 or whatever. Whatever reduces to 12%. So then frequency list would be L2. Calculate and you should get that same screen. So try that. Let me know if it works. I always forget that. So what do you do? Oh shit. You missed a lot of that, didn't you? All right, cool. Yes? You're good? I just don't want to let you go. It's so early. You guys are really, really bummed. I want to do that to you. Oh, before I go too far. One last little thing, and then I will let you out early. Why not? The formula for the mean is this here, remember? An alternate name for the mean, and tell me why this makes sense. If well, let me just tell you. Another name for the mean is the expected value. So in this chapter is where they really start to use that phrase. And really it's what we use if I flip a coin 1,000 times, how many heads would you expect, right? So that's why we call the mean the expected value. You with me? And what's really nice is the formula has the first 3 letters on, expected value. You gotta love that when that happens, right? Why not? They're all letters. Sometimes they actually make words that relate to definitions. It's crazy. So if you see them reference expected value in the homework, that's another name for the mean. We'll see that from here on out every now and again, that phrase expected value. All right, that's plenty. We got plenty far enough.
Okay,
So every Wednesday is the
you just look at what
quiz.
values are in there. So it has to be greater than 1.3. So you can do the same. It has to be less than 4.3. So you add these percentages. Because those are the probabilities.
Oh.
Here, brother.
Oh. The worksheet? You mean not this?
No, the worksheet.
Oh.
If you have it.
What was that worksheet?
The worksheet.
Oh yeah.
My daughter was having like an anxiety.
maybe. Hold on. There we go. Yay. All right. Well, thank you.
What is it?
Oh, it means really good.
Oh, okay. 'Cause I'm like,
You're. So I was a little concerned with some of the answers being very close to the format from the solutions manual. But you're doing really well on the tests and quizzes. I would really only be really concerned, just as long as they're not coming straight from a solutions manual. Or you just know doing them really well that they actually just look right. I don't know. I couldn't really tell. So on one of your homeworks, I think I said careful.
oh,
Right?
that-
And it was
I
because
was gonna ask about that too.
One of the problems, the wording was just like the solutions manual, so I was a little worried that they were coming from there. But your grades are really good, so so I'm not accusing you of anything. I'm just saying if you're checking yourself against it or something, just be careful. But if you're not, then it's just coincidence. Yeah, so don't take it personally.
Okay.
All right.
I was getting confused.